Okay, so this is the smart golf trolley. I'm using a Raspberry Pi camera and Raspberry Pi computer and DSP microcontroller, and I've two custom built H bridges that are capable of carrying the full load current of 17 amps. Um, the tracking is achieved through image processing techniques and OpenCV. I have it configured to track a high-vis jacket. When the jacket is in the center, two motors will be rotating at the same speed. If the jacket goes off in the right direction, the left motor will continue moving and the right motor will stop, so it will actually turn in that direction. The same is true for the left direction. I've used closed loop control, so the closer the colour is to the camera, the slower it goes. The further away, the faster it goes, and it'll come to a complete stop when it's at a certain point in front of the camera. So I'll do a demonstration now. So as you can see there, the closer I am, the slower it goes, and the further away, the faster it goes. So when I move back in now, it will gradually slow down and come to a complete stop. So that's it in a straight mode, so I'll show you now when you need to turn to the left or you need to turn to the right. One wheel will move and the other won't. So if I come to the left, and then back to the center, and then to the side, back to the center, now to the side, center, further away, faster it goes, closer I get, the slower it goes. Okay, so there was a, I don't know why I deleted it. There was a command which showed you the shipments, which will give you a lot, which will give you all the information. When I pull it out of the screen, it goes into idle mode and both motors come to a complete stop. Let's give you a close up now of the setup. If you come down here, this is the Raspberry Pi camera module, the Raspberry Pi computer, and that's just a breakout from the GPIO ports. Over here I have a DSP microcontroller. This here is an LM7805 voltage regulator. It's just dropping down from this 12 volt battery to give 5 volts for the DSP. In here I have two custom built H bridges, and you can see here the heat sinks on top of the MOSFETs. There's large capacitors here for protection against transient voltages. Over there, as I said, is the battery. These are two independent motors and they've independent gearbox. You can see in here where I cut the gearbox in half, because originally it was just one motor with a single axle, so I had to cut it in half to give bi-directional control. Just standard wheels, and then I just have this power pack up here just to supply the Raspberry Pi. I could have come off the 12 volt battery, but it needed additional protection, so it wasn't done. You can see there's two MOSFETs here. They were used for the logic level shifting because the Pi operates at 3.3 and the DSP operates at 5, so communication between the two was an issue. Therefore, logic level shifting was required. If you have a look on my blog, chrisdunsite.wordpress.com, you can find all the schematics and all the code associated with it. Thanks for watching.